Okay, so good afternoon, everyone. Thank you for being here. So today I'm gonna talk to you about the role of artificial intelligence in the modern food technology, in particular on the application of artificial intelligence to the defrost process. So let me introduce myself. My name is Samuele Benfatti, and I'm an artificial intelligence engineer at IGECO. And this is our agenda for today. So we'll start with a brief introduction about IGECO, and then we'll introduce the existing scenario, and then we'll show you our innovative approach, which is AIDA, and we'll conclude with some experimental results, some data about our solution. So first of all, IGECO. We are a company that offers total solutions, so from the hardware, software to the cloud. And we've been acquiring data for more than 16 years. And in this time, we have started monitoring more than 9,000 devices. And we released more than 100 white label clouds. So the existing scenario is, as you know, in refrigeration, we have ice buildup on the evaporator. This is problematic since as ice builds up, we start reducing its exchange, which in turn increases the costs of operation. And so we need to periodically remove this ice, either manually or through some defrost system, which typically is operated at regular intervals. So we have time-based defrost. This is a suboptimal solution since sometimes we defrost too often, and this results in inefficient energy usage since we are heating and then cooling again the cooling element. Or maybe sometimes it happens that we are defrosting not often enough, and this can lead to excessive ice buildup, which then results in problematic food conservation. And in any case, we are problems with wear and tear. So our components need to cycle through defrosting and not defrosting. And this is not optimal. Of course, we would want to improve this time-based system, but there are some technical challenges we need to overcome. So the first problem is appliance variability. So we have walk-ins and cabinets and all kinds of things in between, and each has its own characteristics. We have a great variability in the external environment. So we have different climate classes, different humidities, different temperatures. Temperatures and humidities change throughout the years. And of course, this is very difficult to generalize. And then we have noise interference. So maybe someone loads and unloads the appliance, or someone leaves the door open, and this introduces noise in our system. The second set of problems is the lack of standardized solutions. So we have a plethora of controllers to deal with. We have a costly sensor if we need to add something ad hoc to measure frost, for example. And then we have to deal with legacy devices, which are not easy to retrofit if we need to add sensors. So in general, we prefer not to add new sensor to solve the defrosting problem. And here it comes our solution, so AIDA. AIDA is our artificial intelligence defrost assistant. It's an algorithm that is adaptive to the changing conditions, both of the machine and of the external environment. This is doable thanks to a continuous optimization that the algorithm performs starting from the data it acquires. And in particular, we only need the cell temperature and the evaporator temperature to predict frost formation and then act based on this prediction. In particular, the steps we follow are the following. So we start acquiring data usually from the controller of the 3G unit. So we don't directly interfere with the unit, we just acquire data from the controller, for example, through Modbus. We then filter this data and we apply our model, which results in the prediction we use to decide whether or not to start the frost cycle. If we decide to start the frost cycle, we send the signal to the controller once again. And then in the end, we have a feedback loop, which allows the algorithm to learn from the specific condition it works in. And here maybe the most interesting part, so the experimental results. We tested several different typologies of appliances. And we actually checked that AIDA is able to dynamically adapt to the different situation we put it in. We had some cases where less than 20% efficiency improvement was found, and other cases where more than 60% was found. This really depends on the conditions. So if the appliance is working in really harsh conditions, we haven't really much room for improvement to squeeze out better results. But in the average case, we really got interesting results. And the most interesting part is that the overall operation of the machine was even smoother than before the algorithm. So a more stable cell temperature. Here you can see an example. So this was installation which we monitored for a week. So this is a week of time. And we can see in black the evaporator temperature, in blue the cell temperature, and in light blue the frost request. This is the initial situation where we have time-based defrost, in this case every 6 hours. This is after we applied our algorithm. So still 1 week of data, but we only did one defrost on average every 24 hours. So more or less 58-60% improvement. So what are the benefits of this kind of solution? The first of all is the seamless retrofit. So it's very easy to install it in a legacy machine. We optimize the cooling capacity since we need to defrost less, and we generally work in better conditions from the heat exchange point of view. This in turn improves the food quality, which we can maintain. And of course, we are reducing the energy consumption since on average we did several less defrost than in the base case. Finally, this should result in an extended appliance lifespan, since of course we are stressing less the whole system. We are not, in particular with hot gas defrosting, we have less cycle inversions. So in conclusion, we presented our algorithm, which currently runs on proprietary hardware by IJECO. The whole system is cloud-enabled, so it's part of a greater ecosystem, which also includes monitoring solutions. And that's it, basically. So thank you for your attention. And if you have any questions, I will be available at Hall 5, booth 208. Thank you.